Hi, this is EL6303 again, and doing the probability and stochastic 6303 and homework 10, question number 2. Also asked about from Professor Pilar's book, like the definition of the properties of a stochastic process, and first it's a White-sense stationary process, and the second is independent increment process, and Markov, and a strict-sense stationary process, and the white noise. Explain the understanding properties and examples. White noise is a process of its value different from times like Tj and Ti are uncorrelated. Alright, so begin with White-sense stationary. The most important properties of a White-sense stationary is that the expected value of that process. Um, the first order one is only the a constant is immutable, and an autocorrelation is a matter of the interval length, but it's not the matter with the starting time. And if the signal is the real signal, the autocorrelation get is an even function, and the biggest value and the maximum value is starting at is valued at 0. Um, Yeah, that is pretty much about the White-sense stationary process. And from the property, you can see that the White-sense stationary is stable, um, with two orders, um, because the average doesn't change with time, and the other correlation is only in the matter of the difference of interval length. So no matter, it's kind of like a time invariant system with two order. But if you higher the order, then this property may have gone. So it's not like a strict sense stationary process. And the second question is asked about the independent increment process. Independent increment. Here we create the increment like an xt2 minus xt1 and xt4 minus xt3, and they're independent for any t with a sequence like a t1 to t4. And the most important, the distribution, the random process, is that the Poisson process is an increment dependent process. Maybe if the two on the non-overlapping interval, then the Poisson processes in this they are independent. And the third question asks about the Markov's process. And Markov talks about the right now the event happens is only the matter of the last time. It's not no matter what the former times like. Given them, if we write in the mathematical form, we could write as given a time sequence as a t1 is all bigger, all to the tn, and the probability value for t xt1 is less than x1 under the conditioning with xt2 is less than x2, xt3 is less than x3, blah blah blah, to the xtn is less than xn, which is nothing but the only the probability of xt1 less than x1 valued at xt2 less than x2. It's only in the matter of xt2 time, but it's no matter what's in all the former times xt3 to the xtn, right? And given this um, properties, we could like probably expand it to the chain, and which result in the probability distribution function. No, it's a cumulative distribution function, which is in capital Case F, valued at an x1, x2, and t1, t2, will be enough to characterize the process statistic like a chain. So if you get the two orders, you can get a third order, the fourth order, so on and so forth. So Markov gives us a chain or a method to mapping from the first from now on to the um, later time to the former time. It's like an iterative process. And the fourth question is about the strict sense stationary process. Strict sense is nothing but expected the definition of a White-sense stationary, that is two order stationary, and three sense is an nth order stationary, characterized by this the probability density function, you can shift the time t1, t2, tn to the t1 plus tau, t2 plus tau, to the all the way to the tn plus tau. It's still the time invariant properties here. And the last question asks about the white noise. White noise is read as NT is given T1 and T2, which they're not equal in a regular basis, and the T1 and T2 are uncorrelated. And if we calculate the numerical, the covariance of T1 and T2, which is an expected value as here, we could get a 0 because they're not correlated. They're random. They're basically not correlated anytime in this interval. And the covariance is nothing but the correlation minus 2 main here, which could be read as an impulse response with certain GT. This is clear for if T1 is equals to T2, then you got an impulse, which is exactly the same time. You get the same white noise, and they get a maximum correlation with each other. And that's pretty much about white noise. Thank you.